Like slicers, maps are reference type. If you pass a map to a function that changes the contents of the map, the changes will be visible in the caller. Maps can be constructed using the usual composite literal syntax with colon-separated key-value pairs, so it's easy to build them during initialization. Assigning and fetching map values look syntactically just like doing the same for arrays, except that the index doesn't need to be an integer. An attempt to fetch a map value with a key that is not present in the map will cause the program to crash, but there is a way to do so safely using a multiple assignment.
Channels. Like maps, channels are a reference type and are allocated with make. If an optional integer parameter is provided, it sets the buffer size for the channel. The default is 0 for an unbuffered or synchronous channel. Channels combine communication, the exchange of a value, with synchronization, guaranteeing that two calculations are in a known state.
Go routines. They are called Go routines because the existing terms, threads, coroutines, processors, and so on convey inaccurate connotations. A Go routine has a simple model. It is a function executing in parallel with other Go routines in the same address space. It is lightweight, costing little more than the allocation of stack space. And the stacks start small, so they are cheap and grow by allocating heap storage as required. Go routines are multiplexed onto multiple OS threads, so if one should be blocked, such as while waiting for input-output, others continue to run. Their design hides many of the complexities of thread creation and management. Prefix a function or method call with the Go keyword to run the call in a new Go routine. When the call completes, the Go routine exits silent. Channels of channels. One of the most important properties of Go is that the channel is a first-class value that can be allocated and passed around like any other. The common use of this property is to implement safe, parallel demultiplexing. It's powerful, but if you ask me, it's ad hoc and ugly. Then there's the "we are the language designers, we need stuff you don't know." The Go type system does not support generic types. They are considering adding them at some point in the future, but for now, they don't consider them necessary. Lowly programmers just don't need parametrics, and it would clutter up the beautiful compiler to implement it. The Go language supports a style of object-oriented programming similar to that used in C. Data is grouped together into structs, and then functions are defined which operate on those structs. Similar to Python, the language offers a way to define the functions and then call them so that the syntax is not cumbersome. Structs. Declaring a new struct type is simple as shown in below. Values of this type can now be allocated using the built-in function new, which returns a pointer to the value in memory with all slots initialized to the 0 value. One of the goals of the Go language is to be concise whenever possible, so a syntax is provided that both allocates and initializes the struct at the same time. Once the type has been declared, functions can be declared which take that type as an implicit first parameter. It is important to understand that the self that is passed into move to xy is a parameter like any other, and parameters are passed by value, not by reference. That is why it must be declared as pointer type in order to actually change the value. If it were declared as just point, then the struct that was modified inside the method would not be the same. One at the call side, values are copied when they are passed to a function. They are also discarded at the end of it. Interfaces. Dynamic languages such as Ruby emphasize a style of object-oriented programming that places more importance on what behavior an object has rather than what type that object is. One of the most powerful features that Go brings with it is the ability to program with the duck type mentality and check for adherence to those defined behaviors at compile time. The name given to the behaviors is interfaces. Defining an interface is simple as shown below. That defines an interface with a method for writing a buffer of bytes. Any object which implements that method also implements the interface. No declarations are required as in Java. The compiler just figures it out. This gives the expressiveness of duck typing with the safety of static type checks. The way interfaces behave in Go allows developers to discover their problem types as they write them. If there are several objects that are all they have behavior, and a developer wishes to abstract on that behavior, they can create an interface. Variable declarations. Natural question is, what does it look like? It's basically a C-like, but with a lot of cleanups and simplifications. Every declaration is preceded by a keyword that identifies what it's declaring: type, function, var, or constant. Lots of parents that are required in C have been removed. Type declarations have been cleaned up quite a lot. They have gotten rid of the type declaration garbage of C. In every declaration, the names comes first, followed by the type. So, for example, types are declared after variable names, and all type modifiers precede the types. So, pointer x is a pointer to an x. 3x is an array of 3 x's. The types therefore really easy to read. Just read out the names of the type modifiers. Square brackets declares something called an array slice. Star declares pointer. Size declares an array. So, square brackets pointer 3 pointer int is an array slice of pointers to arrays of 3 pointers to ints. The syntax of Go is close to the C except for the type declarations. Other syntactical differences are the missing parentheses around for and if expressions.
Functions. Functions in Go are amazing. They start off really simply, but by providing a few simple extensions, they let you do all sort of things. To start off, here's a factorial function in Go. Go extends that by adding support for name return values. You can declare the return value as a variable in function header. Then you can assign values to that variable. When the function returns, the last value assigned to the return variable is return value. So you could also write factorial as below.
One of the dominant themes that you will see as I continue to describe it is minimalism. The guys who designed Go were very focused on keeping things as small and simple as possible. When you look at it in contrast to a language like C++, it's absolutely striking. Go is very small and very simple. There's no craft, no redundancy. Everything has been pared down. But for the most part, they give you what you need. If you want a C-like language with some basic object-oriented features and garbage collection, Go is about as simple as you could realistically. To give you one example of that minimalist approach, Go allows you to define types with methods, but there's no such thing as a class, and there's absolutely no inheritance.